Okay, now that we've had our video on standard deviation and we learned how important that is, and we look at this bell curve. We learned now that it was the shape of a bell. That's why it's called the bell curve. But we learned that we have the mean or the average. Okay, we have the mean here, and so things are based on how many lines from the mean. Okay, so then we take our first thing. This is called the deviation score. The deviation score is the plus or minus score showing the difference from the mean on a bell curve. So kind of like we talked about before. Okay, so here's the mean. The mean is this dark line going down the middle. So this would be a +1, +2, +3, and we actually do a +4. And then we come back here and it's a -1, -2, -3, and a -4. So once again, that's a deviation score. So we got these, for years you would get standardized tests and it would say, what's your deviation score? And it says, oh, you got a -1. You're like, oh, well, that's not too bad. I didn't miss much. Oh, that's pretty good. Wow, -1, that's pretty good. Well, what that means is that you were 12% behind whatever the average was. So if you got a +2 and you're like, woo, how about me? I'm really good. Well, we got to be really careful because what's the deal? Well, the deal is it depends on what the mean is. See, this is a problem we have in America. We're looking at all this. We can make the test scores look good or bad. We can massage any data we want to do because all we got to do is change the mean. So you would assume that the mean is average. Well, what does that mean? So if we're going to do a mass score on a test and we're going to go out to the public and we're going to go out to the United States and we're going to say, okay, well, our students are 2 standard deviations above the mean, and the public goes, wow, we're smart. And then the question for us is, as researchers, what's the mean? What's the mean? What did the average kid score? Well, if the average kid scored a 70, okay, which means that's a C, which that's average in there, okay, then wow, look up here where that may be an 82. That's pretty good. That's not too shabby. And we just assume that average means average. But let me tell you about the state of New Mexico because I understand New Mexico data, okay. Guess what? Guess what? The mean wasn't a 70. This will blow your mind, and you look at this and you'll be like, what? What's going on around here? Yeah, the mean was a 38. True, and once again, I'm not bashing New Mexico, but we got to look at this, okay? And then I worked over in Texas, and it was kind of interesting because in order to pass the test, you had to be at the mean, and it was 38%. So we're at 38, or let's say the mean is 38%, okay? Well, that's 38% right. That's a whole lot wrong. So we got to be careful. What's a deviation score? That's important, okay? So wow, so I come over here, so I'm a +3, I'm way over here. I'm doing honking good, but that might be a 70%. Wow. So see, we got to be careful. We say somebody is this percent or that percent or this far from the mean or that far from the mean. We got to be really careful. So once again, we got to think. We can't think like the average public. We've got to think like an educated people, and that's the whole idea behind college. We got to think, and psychology, a big part of this is research techniques and where we're going with this. So the deviation score is good, but we got to know what the mean is. So frequency distribution, how frequent a score occurs. Is there a reason why that score is occurring over and over? What's a normal curve? A normal curve is a true bell curve. All right, and it's a true bell curve. So that means that 50% of the people are this way, and 50% are this way, and 2% are over here, and 2% are over here. If I did a test of the IQ of everybody in this college class, and once again, what's interesting about this college class is we have dual credit, but we also have regular college students taking this. As a matter of fact, we've got some guys in Afghanistan taking this in the military, and to you guys, I say my hat's off. What way to go! And you're serving our country and getting your college credits, and it's exciting to have you in class. So if I were to do an example of a bell curve in this class, it would not be what we call a normal curve. It wouldn't be a true bell curve. As a matter of fact, I probably don't have anybody down here. Everybody, there might be 1 or 2 people down there, but here's my curve for this class. You're not going to be, I'm not going to have people who are mentally handicapped that just can't even deal with this, so I'm going to take off that 2%. I hope some of you are kind of over here, but either way. Now the fun thing about this is in psychology, we got people that are like, oh, you know, my child's a genius. Okay, that's great. You know what? That's not so great. That's a real problem because your child is going to have a tough time dealing with society. So what we're going to find here, we talked about this a little bit on the standard deviation curve. Okay, when we did standard deviation. The bulk of the population is right here, and if you're within this range, you're actually really going to find yourself adapting really well to society and to people. So if you're actually super, super smart and you're like, oh my gosh, I'm over here, before you brag too much, be careful. As we go throughout this class, we'll talk about the difficulties of being here, and we'll talk about the difficulties of being here, and then we'll go and we'll work our way in, and then we can learn a little bit more about ourselves and why we might have trouble dealing with people or situations. So once again, a normal curve is a true bell curve. Then we have a histogram. This is kind of interesting. Histogram is a graph, okay? Histogram is a graph that switches the x and the y axis. It switches the x and y axis on a bar graph. So ordinarily, a bar graph would look like this. We've got our x and our y axis. Okay, let's get lined up here. Okay, so we have our x and our y axis, and here's the different data that's coming out on this. And this is kind of nice. We look at this, and we can read this. We're like, oh, wow, that one stood out. That one was short. But what's the problem with the x and the y axis like this? The problem is we have to go down through the deal. A histogram switches that. So now look what we can do. Now I can have a big printout, and I can draw a line, and I can say everybody under this, wow, we're going to call that group A. Everybody over here on this, we can call group B. So a histogram allows us to analyze tons of data faster than a regular bar graph. So all a histogram does is take a bar graph and switch the x and the y axis. Now then we have something called skewed distribution. Okay, this is data with unevenly distributed. It's data with unevenly distributed data. Okay, so when something is skewed, it means it somehow something has happened to cause it to be off. Something seems wrong. Okay, something is skewed. So, for example, we used to see this a lot on TV commercials. You know, 3 out of 4 dentists recommend Dentine gum. Well, what does that mean? You know what sample? What do we do 4 dentists and was it Joe and Bob and Herb? Did I pick them out? Is it skewed? Did I pick what I want? Did I have was everybody in one area? It's unevenly distributed. Now what is evenly distributed? Well, once again we come back to our bell curve. Do we have a little bit of everybody? Do we have all this? No, everybody was right here. And sometimes on our data, that may be what we're studying. We may be studying people in this subgroup. And if that's the case, then everybody's going to be in that. But when we see a skewed distribution, everything points towards one direction, and we got to look at why it's skewed. Then we have statistical significance. I love this. That means it's not simply due to chance. See, because sometimes we can say we can do this study. We can do this study. We can say, you know, 8 out of 10 people avoid walking on the sidewalk. Well, what kind of study is that? Because it may be that the sidewalk is 100 feet that way, okay, and you've got to walk over there to get on the sidewalk. But what's the chance that we're going to walk over there? Well, I think I'm going to take the shortcut. See, or there might be an alligator on the sidewalk. Did we mention that? That could be a problem. Okay? So what's the deal that it could be just chance that our data occurs? Well, then we go to the levels of significance. That's the probability of chance. Okay? So there's a fire. There's a fire in the building. Okay? All right. What's the levels of significance that people are gonna probably leave class, just get up and leave class? Well, probably pretty good. Why? Because the probability of having a fire in the room and leaving is pretty good. So we got to look at this. How many times do people react and we're like, oh my gosh, look what happened, when really it was just by chance. Or it was something that they would do even without the type of research we're doing. What are the chances that it just happened by chance? What's the probability that would have happened just randomly no matter what we did? Now, error, random variability. Okay? So all of a sudden, so what's variability? variability is difference from the mean, okay? So here's error. Now error in this case is not the true Webster definition of error. Yeah, something's wrong. Error in this case means we need to look at it and see what's going. So here we go, we're charting on a standard curve. I got somebody here, I got somebody here, I got somebody here. I got all these people are samples within our area, and then all of a sudden I got this one guy and he's over here. And I'm like, oh, I sense some error. The error doesn't mean it's wrong. I just got to be like, okay, what is that? Random variability. Everybody fit within this, and then there's one guy over there. Okay, so what caused that guy to be over there? Or gal, or chimpanzee, or whatever we're testing. So we call that an error. Does it mean it's wrong? No, it means that it's different from what we're getting. So we have to look at error. Okay, internal validity.